Hey there, Mr. Weaver here, and this is Module 8, Lesson 3, Negative Exponents. After this lesson, you need to be able to simplify expressions containing zero and negative exponents. Let's learn zero exponent. Our key concept here is the zero exponent property. What this means is any not zero number raised to the zero power is going to be equal to 1. So any number, as long as a is not equal 0 to the 0 power, will be 1. So 30 to the 0 is 1. X divided by y, whatever that happens to be, to the 0 power is 1. 8/3 to the 0 power is 1. We could have 10 billion to the 0 power, and it would be equal to 1. Example 1. Zero exponent. Simplify each expression. Assume that no denominator equals 0. So we have that expression here. We can see that it's to the 0 power. So no matter what we do, this whole thing is going to be equal to 1, because anything to the 0 power equals 1. In the second example, we see a 0 power here, but we do also need to be careful when dealing with it, because only the thing that's raised to that 0 power is equal to 1. So if we have a to the 4th, b to the 0, divided by a to the 2nd, the a to the 4th was not raised to the 0, so that stays. B to the 0 is the only thing that changes to 1, because it's the only thing that's to the 0 power. So we can put 1 in that place. A to the 2 on the bottom stays. Then we can use our quotient of powers, where we're dividing by the same base, so we can just subtract the exponents. 4 minus 2 is 2. So our final answer would be a to the 2nd power. Check your understanding. Select the simplified form of what is given. Pause the video now and complete the check. Check your answer. You should have picked A. How to get that? Let's simplify out what we can. So 56 divided by 8 is 7, which is in all of them. That didn't help. I see a g on the top and the bottom, so I'm actually going to use the quotient of powers. G to the 2 divided by g to the 0 would be 2 minus 0, so still g2. H and h0, this is just 1 here, so I have left with an h. That's secretly a 1 anyway, so 1 minus 0 would just be 1. And then finally I have j11 and j0, so j to the 11 minus 0 would be 11. Or I could have changed all of these to 1s. They would have been gone. I'm dividing by 1, and I'm left with what's on top. So A was my correct answer. Let's learn negative exponents. Any non-zero real number can be raised to a negative power. That power is called a negative exponent. So our key concept here is the negative exponent property. So any not zero number A and any integer n, so where we have a to the negative n, is the reciprocal of a to the positive n. Or we can say the reciprocal of a to the negative n is a to the positive n. What this is going to look like, you're going to see right here. We have a to the negative n. It's going to be the same as the reciprocal of a, so 1 over a to the positive n. Notice when we switch sides of the fraction, it changes its sign. So if it was negative on the top, it's going to be positive on the bottom. If it was negative on the bottom, it's going to be positive on the top. And that's going to be an important thing to remember. So here we can see 3 to the negative 5 is the same as 1 over 3 to the positive 5, which then we can multiply out to get 243. 1 over m to the negative 2, where it's negative on the bottom, is the same as flipping it, the reciprocal, and we get m to the positive 2 over 1, which is just m to the 2nd power. Why these things are important, as we're going through this and we're trying to simplify our expressions, with exponents, a fully simplified expression has certain characteristics. So first, a simplified expression can only contain positive exponents. So if you see a negative one, we have to put it on the opposite side of the fraction bar and make it positive. Each base can only show up once. So we saw in previous lessons where we had our product rules or our quotient rules, we need to make sure the variables only show up once. There cannot be any powers to other powers. We need to use the power to a power rule or the power of a product rule to simplify that out. And all fractions need to be in simplest form. And mainly those fractions are talking about the numbers. So for example, if we say had like 8 to the 24, we would need to simplify that into 1/3. Example 2, negative exponents. Simplify a to the 3rd, b to the negative 4 over c to the negative 2. So to do this, we're going to break things apart into our different variables. So here we have our a's, our b's, and our c's. Notice here, if it was on the top to begin with, we wrote it as a fraction over 1. If it was on the bottom to begin with, we wrote it as a fraction of 1 over that thing. This is because when we need to switch for our negatives, it's easy just to flip it to the other side. If it's positive already, then we can just leave it alone. So a to the third was positive, we can leave it alone. B to the negative 4, we have to flip it down to the bottom, flipping our fraction to the reciprocal. Now we have 1 over b to the positive 4. And then c to the negative 2 was on the bottom, so if we flip it, now it's on the top. Once we have all positive exponents, which we do, we can put it back together. So a and c are the only ones on the top, and then b to the fourth is now on the bottom. So this would be our simplified version of what we started with. Check your understanding. Simplify the expression given and choose the best answer. Pause the video now and complete the check. Check your answer. You should have chosen B. Let's figure out how to get there. So first, 42 divided by 14 is just 3. Here I can see I have r to the negative 2, and then I actually have r to the positive 2 on the bottom. So that would stay on the bottom, but this r to the negative 2 would swing to the bottom. Now I have r2 and r2, which would be r4 on the bottom. So those are taken care of. I have t to the negative 6. There's no other t's, so I'm going to move it to the bottom and make it positive. Here I see u to the negative 3 on the bottom, so I need to swing it up. U to the positive 3 was already there on top. I'm going to move that other u to the 3 up. I have u to the 3 and u to the 3, so u to the 6. So what I'm left with is 3 and then u to the 6 on the top, and r4 and t6 on the bottom. Again, my negative exponents just flipped to the opposite side of the fraction bar, and then combined with any other of that variable that was there already, using the product of powers property that we learned about in lesson 1. Example 3, simplify an expression with negative exponents. So we're going to simplify 3g to the negative third, h to the second, all over negative 36g to the third, hj to the negative 4. So we just kind of saw this in the check. Let's look at how they do it here. So here they grouped together the numbers, they grouped together the g's, grouped together the h's, and the j's. The j is the only one that doesn't have something on the top and the bottom, and since it's on the bottom, they put a 1 on the top. Now let's just go through and simplify what we can, but this time, let's use our quotient of powers as well as our negative exponent properties. So negative 3 over 36 simplifies to negative 1/12. Remember, fractions had to be in simplest form, so now we're good with that. We can see it going all the way. For g, let's use the quotient of powers. So if we have numbers, we can do negative 3 minus 3, which would then be negative 6. We can do h to the second divided by h to the first, so h to the 2 minus 1. And for our j, we can swing it up to the top and make it j to the positive 4 over 1, or just j to the 4th. So simplifying this, we have g to the negative 6 and h to the 1. Then we can't deal with that negative 6, so 1 over g to the 6th. Finally, putting it all together, these two would be over 1. So what is left? H and j4 are on the top, and 12 and g6 is on the bottom, and the whole thing was negative because of that fraction. Check your understanding. Simplify the expression given and select the best answer from below. Pause the video now and complete the check. Check your answer. You should have picked C. So first, if we reduce this fraction, I can divide both of them by 7 and I'd get 5 and 2, which is where our numbers come from. H to the 0, I'm just going to say that's a 1, so that can go with the 5 now. J to the negative 5, let's move it to the bottom and make it positive. K to the negative 2, let's move it to the bottom and make it positive. H to the 2 is positive, it can stay on the bottom. M to the 5, positive exponent, can stay on the bottom. So everything pretty much moved to the bottom. H2, J5, K2, M5. We can see that all at the bottom there. The only thing left on the top was that 5.